There are gold nuggets so famous their names become part of mining history. The Welcome Stranger, the Hand of Faith, the Pepita Canaa, but the largest silver nugget ever discovered was never given a name at all. It simply appeared deep underground in the darkness beneath Aspen, Colorado in 1894, as a gigantic metallic mass so large that miners could not even remove it from the mine in one piece. And technically, calling it a nugget is not even correct, because the silver mass was discovered underground inside a hard rock mine, rather than in an alluvial river system. The proper geological term would actually be a specimen, but since it's historically recorded as the largest silver nugget ever found, for simplicity's sake we'll call it a nugget. Unlike classic alluvial gold nuggets surrounded by rivers over millions of years, the Aspen discovery formed underground inside solid rock. It was a colossal hydrothermal mass of native silver, still attached to its host vein material. Yet even among mineral specimens, this thing was absurd. The mass weighed roughly 2,340 pounds, or more than 1,060 kilograms, and consisted of an estimated 90 to 96% of pure native silver. At modern silver prices, the metal content alone would be worth well over $1 million US, and that calculation ignores the fact that a native silver specimen of that size would likely become one of the most valuable mineralogical objects on Earth if it survived intact today. But it did not survive intact. The mass was simply too large to move through the underground workings of the Smuggler Mine. Miners were forced to cut it apart underground with drills and explosives before hauling the pieces to the surface. Even after being broken up, the largest surviving section reportedly still weighed more than 1,800 pounds or 816 kilograms. And despite being one of the greatest metallic discoveries in mining history, it was never named. No dramatic title, no legendary nickname, no museum pedestal carrying its identity through the centuries. Just an anonymous silver giant hidden inside a mountain. To understand why such an impossible object formed in the first place, you have to go back to the violent geological history of the Rocky Mountains and the strange chemistry that transformed Aspen into one of the richest silver districts ever discovered. The rocks surrounding Aspen were once ancient marine sediments deposited hundreds of millions of years ago beneath shallow Paleozoic seas. Thick layers of limestone, dolomite, shale and sandstone accumulated over immense spans of time before eventually being caught up in the tectonic upheaval that built the Rocky Mountains. During the late Cretaceous and early Paleogene, massive compressional forces associated with the Laramide orogeny pushed huge blocks of crust upward across western North America. Deep fractures formed throughout the region, allowing hydrothermal fluids to migrate through the crust. These fluids were superheated mixtures of water, dissolved metals, sulfur, silica, and salts moving upward from deep magmatic systems. As they rose through faults and fractures, pressure and temperature changed. The chemistry of the fluids changed as well, and eventually the dissolved metals began to precipitate out. In many silver districts around the world, silver remains chemically bound inside sulfide minerals like galena, tetrahedrite, argentite or acanthite, but Aspen was unusual. The chemistry of the hydrothermal system, combined with the carbonate-rich host rocks, created conditions capable of precipitating enormous quantities of silver directly as native metal. That is an exceptionally rare thing in geology. Silver is far more chemically reactive than gold. Gold survives weathering easily and tends to accumulate into waterborne nuggets inside rivers and gravels. Silver tarnishes, reacts with sulfur, and more readily enters mineral compounds. That means giant masses of pure native silver are extraordinarily uncommon compared to gold nuggets. Yet Aspen produced not only native silver, but spectacular examples of wire silver, dendritic silver, and massive metallic accumulations unlike almost anything else found in North America. Part of the reason was the host rock itself. The Aspen district is dominated by carbonate sedimentary rocks, especially limestones and dolomites. These rocks are chemically reactive when exposed to mineral-rich hydrothermal fluids. Instead of simply filling fractures with quartz veins, the fluids often replaced entire sections of carbonate rock with metallic minerals. These are known as replacement deposits. In places, entire zones of limestone were gradually dissolved and replaced by silver-bearing minerals. The resulting ore bodies could become incredibly rich, especially where structural traps focused fluid movement into confined zones. The Smuggler Mine sat directly within one of these highly mineralized systems. Located on Smuggler Mountain, northeast of Aspen, the mine became one of the most famous silver producers in Colorado during the Great Silver Boom of the late 19th century. Aspen itself exploded from a remote mountain camp into a booming mining town almost overnight after rich silver deposits were discovered in the area during the 1870s and 1880s. At its peak, Aspen was producing astonishing amounts of silver. Some estimates suggest the district yielded more than 100 million ounces of silver during its major production years, helping transform Colorado into one of the most important silver-producing regions in the world. The Smuggler Mine was among the richest operations in the district. The mine worked a series of silver-rich replacement bodies and vein systems hosted primarily within the Leadville limestone and associated sedimentary formations. Ore grades could be spectacularly high. Historical reports describe zones containing huge concentrations of native silver mixed with galena, sphalerite, pyrite, and various silver sulfides. But occasionally, miners encountered something far stranger: massive accumulations of nearly pure metallic silver. The famous 1894 discovery reportedly occurred deep underground while miners were following one of the rich ore chutes through the mountain. Instead of ordinary ore, they broke into a gigantic metallic body composed almost entirely of native silver. To the miners, it must have looked unreal. Imagine standing underground by candlelight and suddenly seeing an enormous shining metallic wall emerging from the rock face. Not veins and not disseminated ore, a solid metallic mass. Even today, very few mines on Earth have ever produced native silver bodies approaching that scale. The discovery came during the final years of America's Great Silver Boom. Ironically, the same year the giant silver mass was found, the industry was already collapsing. The repeal of the Sherman Silver Purchase Act in 1893 devastated silver prices across the United States. Mining towns throughout the Rocky Mountains suffered economic collapse almost overnight. Aspen itself was hit hard. Mines closed, workers left town, and fortunes evaporated. Yet the Smuggler Mine continued operating because its ore was so rich. The mine eventually developed an enormous network of underground workings extending deep beneath Smuggler Mountain. Historical records indicate the workings reached depths exceeding 1,000 feet, with multiple levels connected through shafts, drifts, raises, and stopes. Like many mines of the era, operations were brutally dangerous. Underground miners worked in confined tunnels filled with blasting fumes, dust, unstable rock, groundwater seepage, and primitive ventilation. Ore was drilled by hand during the early years before compressed air equipment became more widespread. Heavy ore cars moved through the tunnels carrying silver-rich rock to the surface for crushing and processing. The richness of Aspen ore made the district legendary. In some areas, miners could reportedly see native silver directly within the rock walls. Wire silver specimens formed delicate twisting metallic structures resembling frozen roots or tangled strands of bright metal. Some pockets produced thick sheets of metallic silver growing through fractures like underground metallic trees, but the giant smuggler specimen dwarfed them all. Because it had to be cut apart underground, the discovery never achieved the same cultural immortality as famous gold nuggets. There was no triumphant photograph of a single intact mass sitting beside proud miners, no preserved centerpiece travelling the world. Most of the silver likely disappeared almost immediately into smelters. That alone makes the story feel almost tragic from a modern mineralogical perspective. If the specimen were discovered today, it would almost certainly become one of the most famous mineral specimens on Earth. Museums would compete to acquire it, collectors would value it far beyond its metal content, and it would likely receive a legendary name remembered for centuries. Instead, it became just another shipment of silver from a mining district producing unimaginable quantities of ore during one of the greatest mining booms in American history. Yet the geology behind the discovery remains extraordinary. Large native silver masses require a very unusual combination of factors. First, the hydrothermal fluids must carry enormous quantities of dissolved silver. Second, the chemistry of the surrounding rock must trigger rapid precipitation of metallic silver rather than sulfide minerals. Third, the system must remain chemically stable long enough for huge masses to accumulate instead of being dispersed. Aspen appears to have achieved all three. The carbonate host rocks buffered the hydrothermal fluids chemically, encouraging precipitation. Structural faults and fractures focused fluid flow repeatedly into the same zones, and the immense scale of mineralization allowed silver to accumulate in concentrations almost unheard of elsewhere. Even today, Aspen remains famous among mineral collectors for native silver specimens, but none compare to the lost giant of the Smuggler Mine, a silver mass so large that miners had to carve it apart underground, a metallic object worth more than $1 million in raw silver alone. A geological anomaly formed by ancient hydrothermal systems moving through Paleozoic limestones beneath the rising Rocky Mountains. And despite becoming the largest silver nugget ever discovered, it passed into history without even receiving a name. Perhaps that is the most strangest part of the entire story. The greatest silver nugget ever found was simply too enormous, too industrial, and too deeply buried inside a hard rock mine to become romanticized in the same way as the famous gold nuggets of Australia or California. It was not discovered by a lone prospector beside a creek. It was uncovered by underground miners chasing ore through the darkness of a mountain already overflowing with silver. And somewhere beneath Aspen, hidden inside ancient marine limestones altered by hydrothermal fluids millions of years ago, there may once have been even larger masses still waiting inside the rock. I hope you found this as interesting as I did, and as always, thanks for watching. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.